Hello everybody, welcome to the video. Today we're going to be talking about trapezoids, about how to calculate the area of these trapezoids, and understanding something called the mid-segments. So to begin, what I'd like you to do is actually take a look at this picture right here, and I want to see if you guys can calculate the area of this shape. So go ahead and just pause the video and take a look at this, and on a separate sheet of paper, just, see if you can find the area of this thing, just knowing what you know about geometry. Okay everyone, so welcome back. So here what you should notice is that actually this shape is made up of a rectangle and a triangle. So what I'm going to do is just sort of drop a line like this and realize that those are the two shapes, and we have our two right angles right there. So we're going to find the area of shape 1, which is the rectangle, and the area of shape 2, which is the triangle. So this is shape 1 right here. The rectangle of shape 1 is going to be 5 times 6. The area of the rectangle, is 5 times 6, and that gives you 30 units squared. And since we know that, this distance right here is 5, what that also means is that this distance is 5. So I'm going to write a 5 right here, and we got to figure out the area of this triangle. How are we going to do that? Well, we know that the height is 5, and we also know that the entire distance here is 10, and this smaller distance is 6. So in order to find the base here, it's just going to be 10 minus 6, which gives you 4. So the area of the triangle is going to be 5 times 4 divided by 2, which is equal to 20 divided by 2, which is equal to 10. And then lastly, if you add up the 30 plus the 10, you get the whole area of the shape, which is 40 units squared. So that's the solution there. And oftentimes in geometry, if you're asked to find the area of like an irregular shape, it's helpful to split it up into different shapes and figure out the area of the shapes that you know. So you may have actually recognized this shape right here. It's something called a trapezoid. And so what I want to do is talk about the different characteristics of a trapezoid and how to calculate the area. So this is what a trapezoid is, and what makes a trapezoid is that it's a four-sided shape. In other words, it's a quadrilateral where two of the opposite sides are parallel, just like that. So the two sides that are parallel are called the bases, so we can call them base 1 and base 2, and then also the distance between the base 1 and base 2, this line right here that's perpendicular to both bases, we call that the height. So those are the different sort of characteristics of a trapezoid. So in order to find the area of a trapezoid, we have this formula right here. It's basically going to be, you add up the bases, base 1 plus base 2, you divide it by 2, and then you multiply it by the height. So this formula is going to give you the area of a trapezoid. So I want to talk a little bit about why this formula works. So basically a trapezoid is kind of like a rectangle. These side lengths right here aren't at 90 degrees. So basically what's happening here is that the area is, this average of these bases multiplied by the height. And here's the reason why. The reason why is because the trapezoid, excuse me, has this thing called a median. And what a median is, it's also called a midsegment, by the way, is if you connect the midpoint of these two slanted lines right here and draw a line through them, we call that the median. And that median is sort of the average of the two bases, as you can see. And if I was to take this triangle right here, this small triangle, and flip it over here, and do the same thing with this triangle, and flip it over here, basically what I have is a rectangle where the bottom of the rectangle is actually just the median, right? This distance right here is m, and this distance right here is m, multiplied by the height, which is h. So that's the reason why the area is the median times the height. Okay, in other words, the base 1 plus base 2 divided by 2 times the height. So that's kind of the reasoning why the area of a trapezoid is the way it is. So again, this is what it is. So another way to think about it, the area of a trapezoid is it's just the median times the height. That's another way to think about it. The median times the height. All right, so let's take a look at some examples. Here you're asked to calculate the area of this trapezoid. So you're given all the information, so all you need to do is plug it in and figure out the area. So to find the area, it's just going to be, we're going to use our formula. So base 1, which is 8.9, plus base 2, 3.7, divided by 2, multiplied by the height, which is 7.1, So we can take our calculator actually and figure out what this median is, excuse me, what the area is. So we have 8.9, plus 3.7 divided by 2 times 7.1 gives us an area of 44.73 units. So I'm going to write down the area, 44.73 units squared. Okay, so that's how to find the area of a trapezoid. So suppose you were asked to do something like this. Here you're asked to calculate the missing segment, which is this base right here, knowing that the area is 23. So what are we going to do? Well, once again, we're going to use our formula for the area of a trapezoid. That's base 1 plus base 2 divided by 2 times the height. Plug in all the information that we know, and then use algebra in order to solve for one of the bases. That's the strategy. So here, this 2.6 will be your base 1. We don't know what this distance is, so it's just going to be base 2, and we're going to leave that as a variable. The height is 4.1, and the area is 23. So we're going to plug in all the numbers. So the area is 23. Base 1 is 2.6 plus base 2, which we have to solve for, divided by 2, multiplied by the height, which is 4.1. Okay, so now basically we have to solve for this B2 right here. So the first thing I'm going to do is divide both sides by 4.1, like this, divided by 4.1, divided by 4.1. So 23 divided by 4.1, let's go ahead and figure out what that is. Let's see here, 23 divided by 4.1. That gives us about 5.6 approximately. So I'm going to write down 5.6 equal to 2.6 plus B2 divided by 2. All right. So basically what happened was these two canceled out. So we're just left with this on the right-hand side of the equation. And 23 divided by 4.1 is about 5.6. So then we're going to multiply both sides by 2 and subtract by 2.6 in order to figure out that B2. So it's going to be 5.6 times 2 gives us 11.2. 11.2 equals 2.6 plus B2. And then we're just going to go ahead and solve for B2 by subtracting 11.2 minus 2.6. So minus 2.6 gives us about 8.6. So B2 is approximately equal to 8.6. So that's your solution. And I say approximately because this 5.6 is rounded, but it's still really close to the perfect right answer. Okay then, so in this next example, we're going to try to figure out what the length of the median is. And remember that the median is actually going to be the two bases added together divided by 2. It's just the average of the bases. So we can plug in the B1 and B2 and pretty much just figure out what M is. So the two bases, like I mentioned, are 22 and 56 divided by 2. So this is B2, that's your B1, and then we're trying to figure out the median. So it's basically just the average of the two, right? 22 and 58. So let's just figure out what that number is. It's going to be 22 plus 58 divided by 2. And that gives us, oops, actually this is a common mistake right here. I'm glad I made this mistake. So when you type this into the calculator, you gotta make sure that this is actually in parentheses. Like 51 is nowhere near the average, so you must be wrong. So you just have to make sure that you put the numerator, the 22 plus 58, in parentheses before you continue. So just make sure to do that, and you should get 40. So the median is about 40, is exactly 40 actually, not about. All right. Okay, so let's try this next example. Example 4, it asks you to calculate the length of the unknown base, knowing that the median is 29 and one of the bases is 23. So we're gonna have to use the equation that we know and solve for one of the bases. So remember, the median is just B1 plus B2 divided by 2. Median is 29, and one of the bases is 23. B2 is just a variable, and then we divide by 2. So we're going to solve this equation, multiplying both sides by 2. we get that that equals 58. 2 times 29 is 58, is equal to 23 plus b2, okay? And let me just verify that actually. That was just kind of mental math, but 2 times 29 is 58, okay? And then we're going to subtract 23 to get our answer of 35. So 35 is the second base, 35. So a little bit more of a sort of, creative way of getting this distance is realizing that 29 is the average of the two bases. So if you go from 23 to 29, you're just adding 6, right? And if you add 29 to 6, you get the answer, which is 35. So that's just another way of getting the answer there. Okay guys, so here we're asked to calculate the length of the median, and remember the median is this distance. And we have the information that one of the bases is 20, the other base is x plus 2, and the median is 4x minus 31. So what we need to do is write an equation and pretty much just solve for x and plug it back in to figure out what the median is. So the equation is that the median is b1 plus b2 divided by 2. And we're just going to go ahead and plug in everything that we know. So the median is 4x minus 31. 4x minus 31. One of the bases is 20. The other base is x plus 2. And then we divide that all by 2. Okay, so we can actually combine like terms in the numerator here to clean things up a little bit. We can't really combine like terms on the left-hand side, but here in the numerator, we have that 20 plus 20 plus 2 is 22 plus x divided by 2. And now basically we got to solve for x. So we're going to multiply both sides by 2, making sure to put this in parentheses because we have to multiply this whole thing by 2. So 2 times 4 gives you 8x, 2 times negative 31 gives you negative 62. And the 2's here cancel, so you're left with 22 plus x. Okay, now it's just some more algebra here. We have to add 62 to both sides, all right? And that gives us 8x. The 62's cancel, and we're left with 84 plus x. And then if we subtract x from both sides, like this, I'm just going to continue right here, we get 7x is equal to 84. So we can divide both sides by 7 to get our answer, and 84 divided by 7 gives us 12. So x is equal to 12 in this case. So we can take that sort of x is equal to 12, plug it into right here, and get our answer. So I'll do that on my calculator. It's going to be 4 times 12 minus 31, and that gives us 17. So this should be 17 right here. All right. Now we can actually make sure that the solution is the way it is because, as I mentioned, the median is the average of the bases. So the distance between them, the lengths should be the same. So if this is 20 and this is 17, that's a subtraction of 3. So if you subtract 3 again, this should be 14. So we do 17 minus 3 to get 14. And if you plug in 12 into x right there, you get 12 plus 2, which gives you 14. So that's how we know that the solution is right. So the solution here is 17.